All right, so this will be our last example for today. We're just going to work with a little different material. We'll go with a concrete example. We've got a 24 by 24 foot grid. So you see the columns here at 24 feet on center. And so we're going to end up with just a slab on a, let's actually on a waffle slab. And we'll have beams and girders running in multiple directions. So just get ourselves oriented here, right? This will be the beam, right, running in this direction, and then this will be these over here. These will be the girders, which collect the beam load and then take it to the column. And so we would have some sort of a smaller joist or something smaller working in this direction. So dealing with concrete, we'll end up with a much bigger dead load. The weight of the material is quite substantial. Same live load, just from an occupancy point of view. And so the LRFD approach, we're going to use 1.2 times the dead load plus 1.8 times the live load. So that ends up with about 340 pounds per square foot as the distributed load that we have to deal with in our design. So we'd have to design the slab, right, which would be present right here. So the slab thickness. Right, we've got a 12-foot span on that slab, so we got to always keep into account our units. And it's going to be L over 28, so that gives us about 5.1 inches, which would be close enough to just design a 5-inch slab. Next, our beam. Minimum depth. So this would be on page 26, so it'll be there in just a second. We've got a 24-foot span on our beams. We've got 12 inches per foot, again keeping in account the units, and we're going to divide by 21. I'll show you exactly where that is here in just a second. That gives us a 14-inch depth, which is also going to be known as H in some of these tables. So the beam model that we're going to design, right, we've got a 24-foot span, and it's going to have a distributed load on it. Right, that distributed load is going to come from that 340 and the tributary area, which is going to be 12 feet on each side. So that would give us a W of 340 pounds per square foot times 12 feet. So that's going to give us 4.08 kips per lineal foot. Right, the moment, and so I'll also show you this here in just a minute on page 28. It's going to be 0.8 times the moment from a simply supported element. So in concrete construction, none of it would be simple supported, so we get a moment reduction, and that's based on the moment capacity in the connections. So we're going to use 0.8 times, now the moment equation is still 1/8 WL squared, or WL squared over 8, 4.08 kips per lineal foot, and then the length is 24 feet. That's squared. So that gives us 235 kip feet. So let me take you back to page 26 from the handout. So here would be the L over 28, the minimum depth for the one-way slab. We've got a LRFD, right, load combination, often used for concrete. And right here we've got cast in place. So we'll say that this is a cast in place, and we'll use 80% of the moment from simply supported. So that would be our, right, for something that's being built on site, not being precast, we're going to use 0.8. This throughout when we're dealing with the capacity BH squared over 24. And so that's the quantity that we're going to use right here. This is the beam sizing table. So this is just page 27. And so BH cubed over 24, that's the capacity of the beam size. And so what we need to do is then just check this column. We need something that is bigger than 235. So I just scroll down, and so we've got a couple of different options here. This is not exactly decreasing. It kind of jumps a little bit. And so right here, 288 would work. And then also there'd be a 24 by 12, right? Or we could also use right here 243. That would work as well. So you can use 18 by 18 from the table. So you have to try and choose the one that would be as close to it, as close to 235 without being too much bigger. So really any of these three would work right here. So for the beam, we could end up with an 18-inch by 18-inch design. We'll just also size out the girder. Right, that girder is going to be a different model, and so it's not exactly pinned, but it is just going to be a single point load right in the middle. And so the M is going to be 0.8, and then the equation is 1/4 PL. And so if you go ahead and calculate that out, that's going to be 470 kip feet for the moment. Again, remember that you've got to take the load that's delivered to the girder from two ends of the beam in terms of calculating your p-value right there. All right, and we can use the same minimum depth requirement because we have the same span. So now we are right back into the table, and let's go see what we can find in it. And so we're looking for 470. See if I can bring it over here. 470 looks like about, there would be one right there using the minimum of 14. So that would work right there. 563 would work, so 30 by 15. Again, we're looking for something above 470. Nothing down here would work, so that would do it right there. About 30 by 15 right there. So there we've done a little review of our framing plan sizing.